Hi everyone, welcome back to this video. We are discussing about the loss functions. We started with different types of loss functions. We started with regression loss function. So we will continue with the regression loss function. Mean squared error is one of the most commonly used loss functions in regression analysis and machine learning. It's used to measure the average squared difference between the estimated values generated by a regression model and the actual observed values. The formula for mean squared error is given. So it's a mean squared error, right? So we can see in this equation there is summation of the difference between predicted output and actual output, that is the divided by number of samples or the elements. So it is the average and it is squared, so it is called as the mean squared error. What is n? N is the total number of data points in the data set. Y underscore I represents actual target value for the ith data point. Y underscore I represents the predicted value for the ith data point generated by the regression model. So regression loss function, mean absolute error (MAE) is a frequently used loss function in regression analysis and machine learning. It's used to measure the average absolute difference between the predicted value generated by the regression model and the actual observed values, that is the target value in a given data set. The formula for mean absolute error is as follows. So we can see that 1 by n summation y underscore I minus y cap underscore I, where n is the total number of data points in the data set, y underscore I represents the actual target value of the ith data point, y cap underscore I represents the predicted value for the ith generated by the regression model. So this is mean absolute error. It is not mean squared error, so there is no square here. Then Huber loss combines mean squared error for small errors and mean absolute errors for large errors. It introduces hyperparameters delta that defines the point at which the loss function transitions between being quadratic and linear, making it more robust to outliers. So the formula for Huber loss combines the mean squared error and the mean absolute error as shown here in the slide. So we can see that 1 by n sigma I is equal to 1 to n y to the power n minus y cap to the power 1 to the square, right? And it is conditioned where the y to the power I minus y cap to the power I is less than equal to delta, and for more than delta we use next type of formula. Here n represents the quantity of data points within that given data set, y represents the actual or the factual value associated with each data point, y cap denotes the anticipated or model generated value for each data point, delta determines the threshold at which the Huber loss function shifts from being quadratic to the linear. So here Huber loss combines mean squared error and mean absolute error. So it basically considers how the network goes from quadratic and to the linear. So this is about the regression loss function. In the next video we will see about other loss functions in deep learning. Thank you.